right, everybody, I am here doing some square roots, and we're talking about how to estimate kind of where they are on a number line. So we have an example here. The square root is 26. So I have to think about perfect squares that are around 26. So if you don't know them off the top of your head, it's really good to try to get a sense of what they are and kind of know them. I was told basically when I was a kid that I should probably memorize up to about 15 or 20. So I did do that. So it just helps a little bit without having to use a calculator because these types of questions here, you will not be able to use a calculator with, at least on certain tests. And in my class, I won't let them use a quiz for a calculator. So you do have to be able to do this kind of on your own. So we're going to take a look at some of these numbers. So when we look at square rooting something, the square root of something is making it smaller. So obviously if it's 26, the number that it's being squared by is smaller. So opposites of squaring something is to square root and vice versa. So if we're thinking about something and I'm trying to make it smaller, this is not a division symbol, and I think people get really confused because they look at it and they think it's the division symbol, and it's not. It's a square root button. On a calculator, if you're looking at it on a calculator, I'll just kind of show you what this particular calculator I have here. You can see it right here. That's the square root button right there. Other calculators just have this button without the X on it. So it depends on the calculator that you have. But when you're thinking about going kind of backwards from this, you're thinking about the number that times itself is going to give you this number. So no number times itself exactly is going to give you 26. But we do have some perfect squares that we can use that are helpful. And so when you're looking at perfect squares, I'm just going to write a few of them here so that you can kind of see them. So if I take the number 1 times itself, 1 times 1, or 1 squared, is 1. 2 squared, or 2 times 2, is 4. 3 times itself, 3 squared, is 9. So you can see that these numbers are the numbers that are under the root symbol. So if I was to square root the number 1, I get this 1 number because it's 1 times 1. 4, if I square root it, I get 2. 9, if I square root it, I get 3, and so on and so forth. Now we haven't quite hit 26 yet. So I'm going to just keep going. So 4 squared, or 4 times 4, is going to be 16. 5 squared, or 5 times 5, is going to give me 25. All right, so we're almost to 26, right? So 5 times 5, if I do 6 times 6, or 6 squared, I'm going to get 36. So it's definitely in between 5 and 6. So if I'm looking at number lines, I can put the number 4 right here, 5, 6, and 7. So if I'm looking at trying to put where 26 is, well, 5 times 5 is 25. So the square root of 25 would be right here. And so I'm going to just put that so you can see. So the square root of 25 would be right here. The square root of 36 is 6, because it's 6 times 6. So if I'm looking for where 26 would be, it's definitely really, really close to 25, right? It's not as close to 36 as it is to 25. So it would be on a number line. I'm just going to put a little arrow here. It's going to be kind of like right here. So it's roughly about right here. And so that's how I would do my estimating with a number line and trying to find out the rational numbers and irrational numbers that are located on a number line. If you want more questions like this, find them on my YouTube, Instagram, and TikTok at YouWantAlgebra. These are going to be in the root and exponents playlist.